Okay, let's move to the rules of differentiation on how to use the product rule to do a differentiation of a function. So, for your information, a product rule we will use when you have two different functions that is separated by the process of multiplication. For example, you have equation y equal to x minus 2 multiplied by 2x plus 1. So here you have two different functions. The function 1 is x minus 2 and the second function is 2x plus 1. Okay, so between these two functions, you have a process of multiplication in between. Therefore, you have an option to differentiate this kind of function, which is by using the product rule. So, the formula to use the product rule is, in order to find what is the differentiation of y, which is dy dx, you need to use the formula u multiplied by dv dx plus with v multiplied by du dx. Or we can use the simple notation y prime is dy dx is equal to u v prime. V prime means the differentiation of v plus with v multiplied by u prime. U prime is the differentiation of u. So this is the formula of product rule. How can we use product rule to differentiate our function? So let's see one example here. You have an equation y equal to x minus 2 multiplied by 2x plus 1. So you can see clearly here you have two equations, or you have two different equations. The first one is x minus 2 in the bracket, and the second one is 2x plus 1. So to use the product rule, you first need to separate both functions. One you will denote as u, and another function you will denote it as v. Okay, so let's say we take the first one as u. So our u now is the function x minus 2, and we take the second function as v. So your v here is 2x plus 1. So, for you to proceed to the next step, you need to differentiate your u in terms of x. Therefore, you will get du dx. Okay, and do the process of differentiation as before, which is using the basic technique of differentiation. You need to bring the power. You cannot see the power of x, means that the power is 1. Multiply by, in front here you have 1. So 1 multiplied by 1, you will have 1x. The power is 1, minus with 1, you have power 0. Minus with differentiate constant, you get 0. And remember, x to the power of 0 is equal to 1. So we no need for us to write x to the power of 0. So what you have as your du dx is equal to 1. Next, you need to differentiate your second term, which is v in terms of x. Okay, so use the same technique where you need to bring the power. You cannot see the power here, right? So when you cannot see, means the power is equal to 1. So 1 multiplied by 2, you have 2x. The power 1 minus 1 is 0. And differentiate positive 1, which is constant, is equal to 0. And again, because of we know that the value of x to the power of 0 is equal to 1, so no need to write it here. So now you have your dv dx is equal to 2. So now class, you already have your u, you already have your v, you already have your du dx, and you already have your dv dx. You can simply use this formula of product rule to find your dy dx. So now, to find dy dx, the formula is u. Where is your u? Your u is this one, x minus 2. So x minus 2 multiplied by dv dx. Where is your dv dx? This one is your dv dx. So multiply by 2 plus v. What is your v? Your v is your v is 2x plus 1. So put 2x plus 1 multiply by du dx. So what is your du dx? Your du dx is equal to 1. So multiply by 1. Okay, so now you already use the product rule formula to differentiate. Just left for you to simplify your equation. So this one is dy dx equal to, you can multiply x with 2 outside here. So you have 2x. Negative 2, you multiply with 2, you will get negative 4. Okay, positive 2x, you multiply with 1, you will get 2x. And positive 1, you multiply with 1, you will get positive 1. And then, which one you can simplify? You can simplify 2x, you can plus with 2x, it will become 4x. Negative 4, you can plus with 1, you will get negative 3. So this one is the answer of the derivative for your function by using the product rule. Let's see one example here on the product rule. If you can see here, you have equation y equal to 2x cubed plus x multiplied by x plus 5 to the power of 4. Okay, class, so here is the example where you have two different functions separated by the multiplication. This one is the first function, multiplied by this one is the second function. You cannot expand this equation because you have this one to the power of 4. It's a complicated thing to expand the power of 4. So what you can do is you can use the product rule to find the derivative, the differentiation of this equation. To use the product rule, the first step is you need to separate both equations and denote it as u and v. Okay, so you will take your first equation here as u and the second equation as v. Let's write our u and v. So our u is 2x to the power of 3 plus x, and our v is x plus 5 to the power of 4. Okay, next step, we need to differentiate both equations. So the first equation is u. You want to differentiate in terms of x. You will get du dx. So now you want to find your du dx. Do a two-step differentiation, which is the power 3 here. Bring in front and multiply with the 2. So 3 multiplied by 2, you will get 6x. Here, power minus 1, you have x to the power of 2 plus, okay, here you cannot see the power, you have power 1. 1 multiplied by, you cannot see the coefficient, means you have coefficient 1 in front. So 1 multiplied by 1 is 1. 1 minus 1, so you have x to the power of 0. And we know that x to the power of 0 equal to 1, so we no need for us to write x to the power of 0. So what you have here is du over dx is equal to 6x squared plus 1. Now you already done with u, you need to proceed with v. And if you say v here is a composite function. Okay, that one that we learned before. This one is the composite function. So how can you differentiate composite function? We have 3 steps, don't forget. We want to differentiate v in terms of x, so we will get dv dx. So the first step, bring the power in front and multiply with whatever you have in front. Here you cannot see anything, means in front here you have 1, so 4 multiplied by 1 is equal to 4. In the bracket you just need to copy, and the power is minus by 1, so you have power 3. Don't forget, for composite function we have step number 3, where you need to multiply the whole thing with the differentiation of whatever you have in the bracket. Okay, so differentiate x, you will get 1. Differentiate constant, you always get 0. So differentiate inside the bracket, you get equal to 1. So you can write your dv dx equal to 4 multiplied by 1 is 4x plus 5 to the power of 3. Alright, class. Now, we already have u. we already have v, we have du dx, and we have dv dx. So we can proceed by using the formula of product rule to find our dy dx, where the formula of product rule is dy dx equal to u multiplied by dv dx plus v multiplied by du dx. Okay, so what is your u? Your u is here, 2x cubed plus x. So write it. Okay, 2x cubed plus x. What is your dv dx? You already find your dv dx, which is this one. So multiply by 4x plus 5 to the power of 3. Okay, plus v. What is your v? Your v is x plus 5 to the power of 4. So write it here, x plus 5 to the power of 4. Multiply by du dx. So what is your du dx? You have here 6x squared plus 1. Okay, class, by substituting this value in the formula of product rule, you actually have done your differentiation process. The next step is just the summarizing or simplifying your equation. Okay, so how to simplify your equation? You need to see both equation differently. You have the first one here and the second equation here. So what is in common? What is the term that they share? You can clearly see both of them has x plus 5. This one x plus 5 to the power of 3. This one x plus 5 to the power of 4. So you can take out the smallest one. Okay, you can take out the smallest one. So you take out x plus 5 to the power of 3. You put the square bracket. So you already take out x plus 5 to the power of 3. What you left for your first equation? 4 multiplied by 2x cubed plus x plus, for your second equation, you take out x plus 5 to the power of 3. So you have one more x plus 5. Because in the second equation, we have 4x plus 5. We take out 3, so we left only 1. And multiply by 6x squared plus 1. Okay, and close the square bracket. So next, what you need to do is you just need to expand the whole thing inside the square bracket and simplify. So what I have here is x plus 5 to the power of 3 here remain. Okay, in the square bracket, I expand each and every term. 4 multiplied by 2x cubed, you will get 8x cubed. 4 multiplied by x, you will get positive 4x. Okay, plus x multiplied by 6x squared. So you will have 6x cubed. X multiplied by positive 1, you will get positive x. 5 multiplied by 6x squared, you will get 30x squared. And 5 multiplied by 1, you will get positive 5. Okay, and next we can see which one we can add or minus to simplify our equation. So we have here equal to x plus 5 to the power of 3 inside the square bracket. Here you can see 8x to the power of 3 can be add to 6x to the power of 3. So you will have here 14x to the power of 3 plus 30x to the power of 2. Then you have 4x can be plus with x. So you have plus 5x plus 5 close bracket. So this one is the last answer. Actually, whenever you have put your value inside the formula, you actually have done the process of differentiation of your function by using product rule. The rest here is only the process of simplifying or summarizing your equation. Alright? So, let's see one more example. Here, we have y equal to 2x. Square root x cubed plus 1. Okay, class. Now, you cannot see which one is the first equation, which one is the second equation, because it is in terms of square root. But I believe that all of you are known that square root can be written in the form of power. If you have square root of x, you can change this one to be x to the power of 1 over 2. Okay, so whenever we want to do a process of differentiation, we cannot differentiate square root. So we must change the square root to become a power. So we can write this equation as y equal to 2x multiplied by x cubed plus 1 to the power of half. So now you already can see which one is the first equation and which one is the second equation. So you have 2x here as your first equation and the rest here is your second equation. So these two equations have been separated by the multiplication process in between. Therefore, for us to find the derivative of y, we need to use product rule. To use product rule, the first step is to separate both equations and denote it as u and v. So which one is your u, which one is your v? Let's take the first one as u. So your u is equal to 2x and the second one as v. So your v is equal to x cubed plus 1 to the power of half. Okay, now we want to differentiate both u and v. Okay, differentiate u in terms of x. You will get du dx. Okay, do the basic differentiation technique. Okay, the power here is 1 multiplied by 2 in front. So you have 2. Okay, you have 2 x to the power of 0. So x to the power of 0 is equal to 1. No need to write. So you have 2. And your v is composite function here. So let's differentiate v in terms of x. You will have dv dx. Okay, do the process of differentiation. The first step, bring the power in front and multiply. So you have 1 over 2 in front. And then you just copy whatever you have in the bracket. X to the power of 3 plus 1. X to the power of 3 plus 1. And the power you minus with 1, so you have negative half. Okay, don't forget, whenever you are differentiating the composite function, you have step number 3, where you need to multiply the whole thing with the derivative of whatever you have inside the bracket. So differentiate x to the power of 3, what you will have? You will get 3x to the power of 2. And differentiate positive 1, you will get 0. So you have 3x to the power of 2 here. Alright. So this one is your dv dx. It can be simplified. 3x to the power of 2 can be multiplied by half. So you can write your dv dx as 3x squared over 2 multiplied by x cubed plus 1 to the power of negative half. Okay, so now we want to use the product rule formula to find the derivative, which is dy dx. Okay, so find the derivative, you will get dy dx. The formula is u multiplied by dv dx plus with v multiplied by du dx. Okay, what is your u? Your u is 2x. So write 2x. Multiply your dv dx. What is your dv dx? You have the whole thing here as your dv dx. 3x squared over 2 x cubed plus 1 to the power of negative half. Plus, what is your v? Your v is x cubed plus 1 to the power of half. So just need to write x cubed plus 1 to the power of half multiplied by your du dx. Your du dx is 2 multiplied by 2. Alright, now it's just the process of simplifying your equation. Up to this one, you actually have done the differentiation by using product rule. Okay, so you need to remember product rule is used when you have to differentiate an equation with two different terms that is separated by the process of multiplication. So now, The question is when to use the quotient rule. If before this we have learned on how to use the product rule to do a differentiation, where we use the product rule when we have the equation with two different terms separated by the process of multiplication. So the quotient rule will be used when we have an equation with two terms separated by the process of division. If just now we learn on how to use product rule when we have an equation, for example, y equal to x plus 3 multiplied by x squared minus 2x to the power of 3. This one, you have two different functions, the function number 1 and the function number 2, and in between of this function is the multiplication process. Now, we want to use quotient rule to find the differentiation of a function y. If you have two different terms, let's say x plus 3 divide by the second term x squared minus 2x to the power of 3. Okay, so you have the first term or the first equation here, and you have another equation here, and both equations have been separated by the division process. So to find the derivative of this function, we need to use quotient rule. So similar to product rule, quotient rule also have its own formula, where to find the derivative by using quotient rule, we need to use the formula v multiplied by du dx minus with u multiplied by dv dx divide by v to the power of 2. Okay, so this one is the formula. Okay, so the step is similar, where the first step is to write two different equations into a u and v notation, and then we will find the derivative of u and v with respect to x. Let's see the example here. We have y equal to 2x plus 5 divided by 3 square root of x. So now you have the first equation on the numerator, which is this one will be denoted as u, and the second one below or in the denominator separated by the process of division, this one we denote as v. Okay, so you can write what is your u and what is your v. Your u now is 2x plus 5 and your v now is 3 square root of x, but you need to remember we cannot differentiate square root, so we need to change square root to become a power. Square root of 2 will become the power of 1 over 2, power of half. Now you have your u, you have your v. So what is the next step is you need to differentiate u in terms of x, and you need to differentiate v in terms of x as well. So differentiate u in terms of x, you will get differentiate 2x will give you 2. Okay, you can work it out. And differentiate 5. 5 is a constant. Differentiate constant, you will get 0. Okay, and for v, differentiate v in terms of x. So 1 over 2, you multiply with the coefficient 3 in front, you will have 3 over 2x. The power you minus with 1, you will get negative half here. Alright, so now you already have your u, you already have your v, you have your du dx and also dv dx. What you need to do next is to find the derivative by using the formula of the quotient rule. So formula of the quotient rule is to find dy dx. This one is what we want to find, dy dx, the differentiation of y with respect to x. First, we need to take the value of v. So what is your value of v? Which is 3x to the power of half. You just write 3x to the power of half multiplied by du dx. So your du dx is 2. Minus, okay, the formula is minus, okay, u. What is your u? Your u is 2x plus 5. So just write it here, 2x plus 5 multiplied by dv dx. So your dv dx is this one. Okay, multiply by 3 over 2 x to the power of negative half. Don't forget the formula have to divide by v to the power of 2. So what is your v to the power of 2? Your v is this one, 3x to the power of half. 3x to the power of half, power of 2. Okay, when you already put all the value inside the formula, actually you have done the process of differentiation. As I said before, the next is just the simplifying process of your equation. So the hint of so the tips for you to solve this quotient rule, the differentiation by quotient rule, is no need to do anything to the denominator. Let it be like this. What you need to do, you only need to simplify the numerator, the one on top. Okay, the one in the denominator, let it be like that. Okay, no need to simplify or whatever, but you need to simplify the one on top, which is numerator. So now we want to simplify dy dx. We can see, okay, first we expand this one. 3 can multiply by 2, you will have 6x to the power of half minus, okay, 2x multiply by 3 over 2x to the power of negative half. Okay, 2 multiply by 3 over 2, you will get 3. X multiply by negative 1 over 2, you will get x to the power of 1 over 2. Okay, and then you have 5 multiply by the whole thing here, you will get negative. Okay, be careful because this one is negative for both. Okay, so you have negative 15 over 2 x to the power of negative half. Divide by 3x to the power of half, power of 2. So you can see this one, 6x to the power of half can be minus with 3x to the power of half. So what you will get is dy dx equal to 3x to the power of half minus 15 over 2x to the power of negative half divided by 3x to the power of half, power of 2. Actually, you still can simplify this one, but just let it to be until here. Okay, so this one is how you use the quotient rule to do a differentiation of a function where your function consists of two different equations separated by the division process. Okay, let's see example here. Okay, you need to differentiate the function 2x plus 3 divided by x squared plus 7. So if you write your equation here, you have y equal to 2x plus 3 divided by x squared plus 7. You want to differentiate. And you can see here you have two different functions. The first one on top and the second one in the denominator. Okay, so both functions have been separated by the process of division. So whenever you have two different functions, two different equations separated by the process of division, if you want to differentiate, you need to use quotient rule. If the equation have been separated by the process of multiplication, then you can use the product rule. So the first step you need to do when you want to use the quotient rule is you need to separate both equations into the notation of u and v. So let's see the first one, the one on top is u and the one in the denominator is v. So you can write your u as 2x plus 3 and your v now is equal to x squared plus 7. Okay, so next step is you need to differentiate both u and v with respect to x. So differentiate u with respect to x, you will get du dx. Okay, so differentiate this one, you will get 2, and differentiate constant, you will get 0. And differentiate v with respect to x, you will get dv dx. Okay, differentiate this one, the power bring in front, you will have 2x. 2 minus 1 is equal to 1, so 2x to the power of 1. and differentiate constant 7 is equal to 0. So now you already have your u, you already have your v, you have your du dx, and you have your dv dx. What you can do next is to find the differentiation of y, which is dy dx, by using the formula of quotient rule, which is v multiplied by du dx minus u multiplied by dv dx. Don't forget to divide everything with v to the power of 2. So now let's put all the value inside the formula. So you have v here. Your v is x squared plus 7. So x squared plus 7 multiplied by your du dx. Your du dx is 2 multiplied by 2 minus your u. Your u is 2x plus 3 multiplied by dv dx. Your dv dx is 2x. Divide everything by v to the power of 2. So your v is here. Your v is x squared plus 7 to the power of 2. So hint that I gave you before, don't do anything to the denominator. You just need to simplify the one on top, which is the one in the numerator. So let's open the bracket. Let's expand this one. So you have 2 multiplied by x squared. You have 2x squared. 7 multiplied by 2. You have 14. Okay, negative here. So 2x multiplied by 2x. You have 4x squared. Negative here. So 3 multiplied by 2x. You have negative 6x. And the denominator, you just need to copy everything. Okay, so you can see here what you can simplify. 2x you can minus with negative 4x squared. So you will have negative 2x squared minus 6x plus 14 over x squared plus 7 to the power of 2. So this one is the derivative of your function y, or it can be written as dy dx. Okay, so this one is how I find the derivative of a function by using quotient rule. Okay, so for the second one here, you have y equal to x cubed plus 1 divided by x squared minus 2. So this one also the same, because both equations have been separated by the division process. So you need to use quotient rule. So you will let this one as your u. Okay, your u is equal to x cubed plus 1, and on the denominator, it will be v. So your v is x squared minus 2. So next, you need to differentiate both your u and v with respect to x. So you will have your du dx and dv dx. Okay, your du dx will be 3x squared. Differentiate plus 1 is 0 because it's constant. And your dv dx will be 2x. Differentiate negative 2 is 0 because it is a constant. So now you already have your u, you already have your v, you already have your du dx, and you already have your dv dx. You just need to substitute inside the formula of quotient rule, which is this one, okay, to find dy dx. So you want to find dy dx now. Okay, the formula is v multiplied by du dx. So your v is x squared minus 2 multiplied by du dx, 3x squared, minus u multiplied by dv dx. So your u is x cubed plus 1 multiplied by dv dx, which is 2x. Okay, divide by v to the power of 2. So your v is here, x squared minus 2 to the power of 2. Okay, and don't forget that no need to do anything to the one in the denominator. You just need to simplify the one in the numerator. By putting all the values inside the formula of quotient rule, you actually have done your differentiation process. The next process is only for simplifying your equation. So you have here your dy dx. Let's expand whatever we have in the numerator. Okay, so x squared you can multiply by 3x squared. You will get 3x to the power of 4. Negative 2 you multiply by 3x squared. You have negative 6x squared. Here is negative. Okay, so negative x cubed multiplied by 2x, you will get negative 2x to the power of 4. Negative, okay, 1 multiplied by 2x, you will get 2x. Divide by, just copy whatever you have in the denominator, x squared minus 2 to the power of 2. Okay, class. Now, 3x to the power of 4 can be minus with 2x to the power of 4. So you will have x to the power of 4, 1x to the power of 4, minus 6x squared minus 2x divided by x squared minus 2 to the power of 2. So this one is the final answer, which is the derivative of your function y by using the quotient rule. Okay. So we have done with the topic of differentiation. I believe all of you now know the first principle of differentiation, how to differentiate a function by using basic technique of differentiation, how to differentiate the composite function by using either chain rule or formula, and how to use product rule and quotient rule to do a differentiation of a function. So now we will move to the next topic, which is integration, in the next video. So let's check it out.